No, sir.
No, sir.
Yes. Okay, now I think it is visible.
Yes, sir.
Right.
So you are well acquainted with the term matrix and its operation. Let us have a preliminary class to refresh your uh, ideas gathered during your intermediate and graduation days. So what is a matrix? Anybody?
Arrangement of numbers in rows
Anybody?
and columns. Equal number of
Okay, it is a arrangement in rows and columns, rectangular or your rectangular or square form. Anybody else? So in the screen there is a definition, and you are almost very much correct in the definition. Matrix may be defined as a square or rectangular array. That may be a square array or a rectangular array of numbers or functions that obey certain laws. So in the rectangular or square array, you might have some function or you might have some numbers as shown in the screen, and it obeys certain laws, or that is known as matrix operation. Are you getting it? Okay. So if there is any doubt, you can ask at the end of the 2 hours class. So you can see here a 1 cross 1 matrix, 2 cross 2 matrix, 1 0 0 minus 1, A B C D E F, 2 cross 3 matrix, and M cross N matrix, where your A11, A12, so on so forth, A1N, A21, A22, so on so forth, A2N. Similarly, you have AM, your AM1, AM2, so on so forth, AMN. So these are the examples of matrix. So here are rows. Your A11, A12, so on so forth, A1N represent a row. And you can see in your 2 cross 3 matrix, your ABC represent one row, DEF represent another row. Similarly, AD represents one column, B represents another column, and CF represent another. Similarly, in your M cross N matrix, am I audible?
Yes, sir.
Okay. So similarly, your M cross N matrix, your A11, A12, up to A1N represents one row, and A11, A21, so on and so forth, AM1 represents one column. So this you know. So the capital letters of the alphabet are used to denote matrix, and the actual matrix is enclosed in parentheses. So you can see a matrix can be represented as capital A, capital B, capital C, capital X, capital Y, capital Z, so on and so forth. And your parameter, in the parentheses, you have your small letters like A and your subscript 1 1, A subscript 1, 2, so on and so forth. So each element is represented by your normal letters, and your matrix is represented by capital letters, or your elements are represented by small letters. So matrix A is of the order of 4 cross 4 as shown in the screen. It is a 4 cross 4 matrix, and your Aij are called matrix element. Your here Aij is equal to A11, A12, A13, A14. In the screen you can have your A, B, C, D, E, F. These are called matrix element, and your Aij is it represents a matrix element. Or your A23, A subscript 2, 3 is an element of the second row and third column you can see. Similarly, your M cross N matrix with M is not equal to N is called rectangular matrix. So if in a M cross N matrix, your M is equal to N, it is a square matrix. And if A is not equal to N, it is called a rectangular matrix. So you know some of the matrix of operations, equality of two matrix, addition, subtraction, then different properties, that is scalar multiplication, identity, matrix addition is associative, and so on and so forth. Matrix multiplication or inner product, like that. So you can see in the screen, this this you have already well acquainted with. Equality of two matrix, if XYZ is equal to 1, 2, 3, then X is equal to 1, Y is equal to 2, and Z is equal to 3. Similarly, in M cross N matrix, you can have the similar equality operation. Similarly, if you have A11, A12, A21, A22 plus B11, B12, B21, B22, there are two matrices. If you add them, or two matrices is added, then the resultant matrix will be A11 plus B11. First row, first element of the first row of the first matrix plus first element of the first row of the second matrix constitute the first element in the resulting matrix after the addition. Please mute yourself. There is a background noise. Am I audible? Yes. Similarly, in the second element of the first row, and if you add it with the second element in the first row, in the second matrix, then you will have the second element of the first row of the resultant matrix. You can see here in the screen as shown in equation 1.1. So similarly, matrix addition is being performed. And addition of matrix is commutative. Your A plus B is equal to B plus A, where A and B are two matrices. And you can see here an example. If A is equal to 1, 2, 3, 4, and B is equal to 2, 3, 4, 5, if you have your A plus 1, it will be 3, 5, 7, 9, and you will have B plus A is equal to 3, 5, 7, 9. Your A plus B is equal to 3, 5, 7, 9. B plus A is equal to 3, 5, 7, 9. So it is your matrix addition is commutative. The matrix addition is also associative. A plus B plus C is equal to A plus B plus C. Okay. Similarly, identity matrix for addition is 0. A plus 0 is equal to 0 plus A is equal to A. Scalar multiplication of matrix. So, if you have your A is equal to 1, 2, 3, minus 1, then your 5A is equal to 5 will be multiplied with the each element in the matrix element. 5 multiplied by 1, so the first element of the resultant will be 5. 5 multiplied by 2, so 10 will be the next element. 5 multiplied by 3 is equal to 15, that will be another element. 5 multiplied by minus 1, that is equal to 5. So that is another element. So A multiplied by 5, then 5 will be multiplied with each of the element to have the resultant matrix. Similarly, if we multiply A with minus 1, then you will have minus 1 multiplied by A is equal to minus A, minus 1 multiplied by B is equal to minus B, minus 1 multiplied by C is equal to minus C, and minus 1 multiplied by D is equal to minus D. So this is all about scalar multiplication of matrix. Similarly, you can have a inner product. So what is an inner product? You can see in the screen. If A is equal to A11, A12, A13, A21, A22, A23, A31, A32, A33, and B is equal to B11, B12, B21, B22, B31, B32, then the resultant A plus AB, the resultant AB, and the inner product, which is called the inner product, can be written as shown in the screen. Your A11, the first element, first row में जो A11 that will be added with AB1, then A12 will be added with the first column B21, and A13, the last element in the first row will be added with the last element in the first column B31, A13 plus B31. Similarly, in the second element you can have your first row and second column. Similarly, the second row first element will be second row first column, and the second element in the second column will be second row and second column. Okay. Similarly, third row and first column will give you the last element in the first element in the last row, and your last row and second column will give you the last element in the last row. Are you getting it? You can see in the screen. So there is an example. If A is equal to 1, 0, 0 minus 1, and B is equal to 0 minus I 0, which you will have your in quantum mechanics Dirac matrix. These are Dirac matrices. So you will have AB is equal to 0 minus I 0. So this is nothing but inner product of AB. Similarly, BA will be also 0 I 0. So it is not commutative. So inner product does not obey commutative law, so it is not a commutative bracket. Similarly, associative, inner product ABC is equal to AB multiplied by C. So here are some examples. AB is equal to 0 does not imply that either A or B is equal to 0. This can be seen in the screen. And your A plus B square is not equal to A square plus B square plus 2AB. You can see here. The proof is shown in the screen. Similarly, if I is the identity matrix of any order, then I square is equal to 1. You can see here I is equal to 0, 1, 1. For example, 0, 1, 0, 0, 0, 1. Then I square is equal to I dot I is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay. If a matrix A and identity matrix I are of the same order, then A plus I square is equal to A square plus 2A plus I. So the solution is like this. And so you can have your A plus B multiplied by A minus B is equal to A square minus B square if and only A comma B is equal to 0 in commutative bracket. So you can see A comma B in commutative bracket is equal to 0. So your AB is equal to BA. So A plus B into A minus B is equal to A square plus AB minus BA plus B square, and A square minus AB plus AB because it obeys the commutative law. Minus B square, which is equal to A square minus B square minus AB plus AB cancels out. Then, like inner product, there is a direct product, which is known as Kroneker's product, So if A is a M cross M matrix and B is a N cross N matrix, then there is a direct product, which can be written as shown in the screen. C is equal to A direct product B. So your C alpha beta is equal to Aij B KL. So if alpha is equal to N into I minus 1 plus K and beta is equal to N into J minus 1 plus L, then your A is equal to A B C D and B is equal to E F G H, then your Kronecker product of A and B will be AB, B small a capital B, small b capital B, small c capital B, small d capital B. So your AB, BB, CB can be evaluated as shown in the screen. So also your DB and your C is equal to your Kronecker product of or direct product of AB. So that is equal to AE, AF, BE, BF, AG, AH, BG, BH, CE, CF, DE, DF, CG, CH, DG, DH. Are you getting it? So you can see in the screen and you can have an idea.
Sir, can we have these notes?
I can. You can have any of the book and you can write down these things in your notebook. Okay, you can see your suits. Look, there are 4 elements: AB, BB, CB, DB. Now evaluate AB. This will be AE, AF, AG, AH, and you will place it in the first part of the resultant. AE, AF, AG, AF, C. In the hence C is equal to AE, AF, AG, and H. Then your BB that will be placed in the second part. B, BF, BG, BH. Similarly, your CB, that will be placed in the lower part, left hand side lower part. That is C, CF, CG, CH. Similarly, DB is equal to D, DF, DG, DH. That can be right hand side lower part. Okay, so you can place this like this. You can evaluate AB, BB, CB, DB, and you can place in a matrix format, and you will have C is equal to Kronecker product of A and B. So I have told you Pauli spin matrix in Dirac delta in Dirac notation, PAM Dirac. So your alpha, your sigma 1 is equal to 0, 1, 1, 0. This represent electron spin 0, 1, 1, 0. Similarly, sigma 2 is equal to 0 minus I 0. Sigma 3 is equal to 1, 0, 0, minus 1. These are Pauli spin matrix, and this is in Heisenberg picture. And your unit matrix will be I is equal to 1, 0, 0, 1. So you can evaluate sigma 1 Kronecker product with sigma 2 Kronecker product with sigma 3 Kronecker product or direct product with sigma 1, and sigma 1 with the direct product with I or Kronecker product with I. So you can have your sigma 1 Kronecker product sigma 2 is equal to your 0 sigma 2, 1 sigma 2, 1 sigma 2, 0 sigma 2, and you will have your 0, 0, 0, 0. Then the 1 sigma 2 will be 0 minus I 0. 1 sigma 2 is equal to 0 minus I 0. 0 sigma 2 is equal to 0, 0, 0, 0. Similarly, your sigma 2, sigma 3 Kronecker product, you will have your 4 part in the resultant matrix. Your 0 sigma 3 is equal to 0, 0, 0, 0. Minus I sigma 3 is equal to minus I 0, 0, I sigma 3 is equal to 0, 0, I minus 1, minus I, and your 0 sigma 3 is equal to 0, 0, 0, 0. Similarly, your sigma 3, the Kronecker product sigma 1 will be your 1 sigma 1, 0 sigma 1, 0 sigma 1, minus 1 sigma 1. And the result will be shown in the screen 0, 1, 1, 0, then in the right hand side 0, 0, 0, 0. Then in the left hand side in the lower part 0, 0, 0, 0. Then right hand side in the lower part 0, minus 1, minus 1, 0, and this completes your Kronecker product of sigma 3, sigma 1. Please mute yourself. Okay, there is a background noise. Similarly, Kronecker product of sigma 1 I will be nothing but 0 I, 1 I, 1 I, 0 I. So 0 I will give you 0, 0, 0, 0. 1 I will give you 1, 0, 0, 1. 1 I will be rewritten in the left hand side in the lower part 1, 0, 0, 1, and your 0 I will be 0, 0, 0, 0. Okay. So similarly, you can have your direct product or Kronecker product. Then we'll discuss linear transformation. So what is linear? Anybody? What do you mean by linear? Please raise your hand.
Variable power 1 thibo.
Yes, yes. What is linear?
F is equal to A1 X, X1, B1, Y1, similarly to power thibo 1 variable.
Oh, that is in geometry. So what is the general meaning of linear? Linear and non-linear.
A straight line.
That line
Linear is something very straight.
Straight line.
Linear is something very straight in a line. The earlier the boy has aptly remarked the exact equation. What is transformation? Transformation is change from one form to another form. Am I right?
Yes, sir.
So transformation is something associated with the word change, and linear you have aptly remarked. So a set of equation, let us consider x is equal to ax by, y is equal to cx dy. So xy can be represented in a matrix form, and you can have your abcd in one matrix and multiplied by x, y. So this can be also written as r is equal to mr, where r is equal to capital R, that represents a matrix, that is x, y in matrix form, and your m is equal to abcd in matrix form, and small r is equal to xy in matrix form. So your abcd are suppose constants. For every point x comma y, these equations give us a point capital X comma capital Y. So if we think of each point of the x comma y plane being moved to some other point, with some points like the origin not being moved, we can call this process a mapping or transformation of the plane into itself. So it will transform or it will change from one center to another in a plane. All the information about this transformation is contained in the matrix M, that is ABCD. So we can say that this matrix is an operator which maps the plane into itself. So your M is an operator that maps the plane into itself. Any matrix can be thought of as operator on conformable column matrix small r. Since M R1 plus R2 is equal to M R1 plus M R2 and M XR is equal to KMR. So M is a linear operator. So M is a linear operator. It changes the plane or transform the plane into itself and linearly. So equation shown in the picture can be interpreted geometrically in two ways. So we can have in figure 1, you can see figure 1.1, figure 1.2. Figure 1.1, what happened? Figure 1.1, you can see small r position vector, your small r or radius vector small r can be represented as x comma y, and capital R is represented as capital X comma y. Similarly, in figure 1.2, your xy plane, you can see xy plane, and when x is rotated about an angle, and you can have your x dash as the axis, and y is rotated in a counterclockwise direction, and the resultant position will be y1. So it is a rotation. So you can say one set of coordinate axes and the vector r has been changed to the vector capital R by the transformation. So in the second figure, you have two sets of coordinate axes. Two sets of coordinate axes. You can see here x comma y and x dash y dash. If we consider it in xy plane, you have your x comma y. If you consider the point in x dash y dash plane, you have x dash y dash as the coordinates. And one vector r is equal to r dash vector with coordinates relative to each set of axes. So this time the transformation x dash is equal to ax plus by and y dash is equal to cx plus dy. You can have your normal trigonometric rules, and you can see that x dash is equal to ax plus by and y dash is equal to cx plus dy. So you can write x dash y dash in matrix form is equal to ABCD multiplied by xy, or r dash is equal to MR. So you can see M remains as if. So this tells us how to get the components of the vector r is equal to r dash relative to axis x dash y dash when we know its components relative to axis x comma y. So your orthogonal transformation is a linear transformation. Here it is a orthogonal transformation, and it is also a real transformation which preserves. Okay, so this is all about linear transformation, and you can have this as shown in figure 1.1 and 1.2. So there are some special matrices and which are related to given matrix A, and it can shown in figure table 1.1. Your name of the matrix, notation of it, how to get it from T, small t. So transpose of A or A transpose, this can be written as A superscript capital T, or A, or you can see A bar or A dash or A superscript small t. And you can have it by interchanging rows and columns. So what is transpose? If you interchange the rows and column, you will have the transpose of the matrix A, and which can be written as A transpose or A bar or A dash or A T. Again, another thing is complex conjugate of A. So how can you get complex conjugate? By taking the complex conjugate of each element in the matrix. Suppose there is A, then B, C, D. So complex conjugate of small a is equal to A star. complex conjugate of B is equal to B star, complex conjugate of C is equal to C star, complex conjugate of D is equal to D star. So the resultant matrix which will be written as A bar or A star can be written as your in matrix form A star, B star, C star, D star. Then your transpose conjugate, which is also known as Hermitian conjugate. Okay. So this is written as A dagger. This is also known as Hermitian adjoint. A dagger, A superscript, a cross symbol, or a Jesus symbol. A superscript, the cross symbol as shown in Jesus Christ. So how can you get it? Take the complex conjugate of each element and transpose it. You have to first take the complex conjugate of each element in the matrix, then transpose it. Transpose matlab interchange the rows and columns. Make the row into column and column into row. This is Hermitian adjoint or transpose conjugate. What is the inverse of A? Which is written as A superscript -1 or A inverse. This is nothing but A M inverse, M superscript -1. This will be evaluated by using the formula 1 by determinant of M whole multiplied by C to the power T. So where Cij is equal to cofactor. Cij cofactor. So then similarly you can have your inverse. So there is another set of names for special types of matrix which can shown in figure 1.2, symmetric matrix. So if it satisfies the condition A is real and A is equal to A transpose, skew symmetric matrix, A is equal to A transpose and A is real, or anti-symmetric matrix. Orthogonal matrix, A inverse is equal to A transpose, A is equal to real, inverse is equal to transpose. Purely imaginary matrix, A is equal to minus A bar. Hermitian matrix, A is equal to A dagger. It's a transpose conjugate. Anti-Hermitian, A is equal to minus A dagger. Unitary matrix, A inverse is equal to A dagger. Normal matrix, A dagger is equal to A dagger A. Okay, so A and A dagger will commute. Then your orthogonal matrices. A matrix A is orthogonal if its transpose is equal to its inverse. That is, A transpose is equal to A inverse. So you can have this as shown in the screen. A transpose multiplied by A is equal to A inverse multiplied by A is equal to unitary matrix I. So this can be like this. So if you have a rotation matrix, A is equal to cos phi, sin phi 0, minus sin phi cos phi 0, 0, 0, 1, then your A transpose is equal to cos phi minus sin phi 0, sin phi cos phi 0, 0, 0, 1. So A transpose multiplied by A will be I as shown in the screen. Then your unitary matrix. Matrix A is labeled unitary. Am I audible?
Yes, sir.
Yes, sir.
Matrix A is labeled unitary if A dagger is equal to A inverse. And if your A is a real matrix, then A dagger is equal to A transpose star is equal to A transpose. Therefore, real unitary matrix are defined as A transpose is equal to A inverse. Is the screen visible?
No,
No,
sir.
sir.
No, sir.
No, sir.
There is some problem. No, there is some problem. The screen is not visible maybe due to network problem. Let us try it again.
No.
No. No, the screen is not visible. So in the desktop, there is some problem. Let us wait for some time. If
I think
the
due to
internet
network
will be
issue.
resumed, they will have it. Anybody? Right. बोलिए कुछ कोई बोल रहे थे.
Sir, please provide your notes.
Yes, let us have the class first. And you have your IGNU material. You can go through this and let us think. I can also give the notes if there will be some need of it.
Sir,
Are you
when we
getting
make
this? Are you getting it? समझ में आ रहा है कुछ?
थोड़ा बहुत sir.
अच्छा, तो you go through your IGNU material block 2. Okay? Block 2 में मैट्रिक्स 1 मैट्रिक्स 2 है, उसको थोड़ा आप देखिए.
Sir, क्या volume 1 या volume 2?
नहीं, you have 5 blocks. Block 1, block 2, block 3 mathematical physics MPH 001. MPH 001 mathematical methods in physics.
Block
So the
6.
block 2 in the course material will be vector space matrices and tensors.
Okay.
Unit 6, 7, 8, 9. Are you getting it?
Yes sir, yes sir.
So वो आप देख के आइए.
Sir, when we make our form fill up for exam,
कब है आपका एग्जाम?
दिसंबर के लिए.
अरे कोई बात नहीं, ये 3-4 महीना हो रहे.
सर
ठीक है,
फॉर्म फिलअप कब होगा?
मुझे पता नहीं. आई एम नॉट द इग्नू पर्सन.
Okay,
I
sir.
am external man. You can have this from your IGNU regional center. Okay.
Okay, sir. Thank you.
So today there is some internet problem. So today we have a 2 hours class, 1+1. So let us stop here and we shall start it from tomorrow since it is the first class. Okay.
Okay,
सर
sir.
आज और कोई क्लास नहीं सर, आज और कोई क्लास नहीं होगा?
नहीं, अभी नेटवर्क नहीं आ रहा है, थोड़ा वेट करते हैं 5-10 मिनट. अगर आता है तो कंटिन्यू करेंगे. अगर नहीं आता तो क्या कर सकते? Let us disconnect and connect again.
Okay, thank you, sir.
No, same problem.
नेटवर्क का इश्यू इसीलिए नहीं हो पा रहा है.
हाँ, कोई समस्या है और यहाँ हमारा बड़ा समस्या है क्लाइमेट में.
इसीलिए सर.
यहाँ हमारा बाढ़ चल रहा है और सारे कनेक्शंस टूट गया.
सर आप कहाँ से बोल रहे हैं?
हिमाचल प्रदेश. हिमाचल प्रदेश, यहाँ 2-3 जिलों में बाढ़ चल रहा है और बड़ा भारी नुकसान हुआ है.
ओ,
ठीक है, सो लेट अस हैव दिस इन द नेक्स्ट क्लास. ये नहीं हो रहा है. थैंक यू.
Thank you, sir.
नमस्ते.
Hello. 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 Am I audible? Hello. ଶୁଣା ଯାଉଛି କି?